Dear students, first let me ask you a soul-searching question. Have you seen the plant in the image? Perhaps you don't recognize it, but I believe many students have definitely eaten it. This is the famous rosemary, the sole ingredient of lamb chops and steaks. This family has many other plants everyone is very familiar with, like the mint leaves in your lemon water, lavender in sachets, perilla in Western cuisine. These plants all belong to the Lamiaceae. Lamiaceae we're discussing today. Lamiaceae is an important family in the plant kingdom, containing about 230 genera and over 7,000 species. Besides the aforementioned mint, perilla, lavender, and other economic crops, there are also medicinal plants like motherwort and henbit. But what we're discussing today are weeds that threaten farmland, like hemp nettle and clinopodium. Let's first see how to identify these plants. The common characteristics of Lamiaceae plants above many include square stems, opposite leaves, bilabiate corollas. Fruits are 4 nutlets. These characteristics are both their ID cards and our keys to identifying them. For example, Mossula has square stems, opposite leaves with wrinkled leaf surfaces. Clinopodium has densely clustered verticillasters, like balls, resembling windmills. Hemp nettle, Lamium barbatum, leaves resemble sesame leaves, but blooms white bilabiate flowers. These morphological features help us quickly lock onto their identity. Next, let's understand the survival wisdom of these Lamiaceae weeds. Lamiaceae weeds have flexible and varied reproduction methods, occupy territory fast, accurately, ruthlessly, and follow a double insurance strategy. For example, ground ivy, Guachoma longituba, can reproduce both by seeds and by vegetative reproduction through stolons. One stem segment falling on ground can root and form a plant. Mint, Mensa canadensis, expands territory through rhizomes, division, cuttings, and seeds in multiple ways. Lamiaceae seed germination conditions are extremely broad, don't require strict cold stratification or light, can even germinate in semi-shade barren soil. For example, henbit seeds can sprout even in broken soil in wall-corner brick crevices. This multi-front combat survival strategy makes them permanent residents of farmland. Additionally, Lamiaceae weeds have extremely strong adaptability. Their environmental adaptation ability is amazing. From comfort zone to hell mode, they can handle it. For example, basil thyme is drought tolerant, tolerates poor soil, often grows on hillsides, roadsides. Henbit, Lamia and Plexico can complete its life cycle, even in cold regions. From flowering to fruiting takes only a few months. Stone calamint can even flourish in barren soil on field ridges and ditch edges. And even without rain for 7 consecutive days, can still keep some leaves fresh. Ground ivy growing close to ground, even if trampled by pedestrians or vehicles, adventitious roots at stem nodes can quickly regenerate. Within days, can recover to crawl all over the ground state. Lamiaceae plants' strong adaptability is also related to their morphological structure. Most Lamiaceae weeds, like self-heal, henbit, grow square stems. This square tube structure is stronger than cylindrical stems, can support plants to squeeze out space in crowded weed clusters, competing for light. Fine down covering stem and leaf surfaces is like a sunscreen and moisturizing film. Both reflect some sunlight reducing scorching and locks in water vapor on leaf surface. In drought or strong light environments, like roadsides, wastelands, reduces water loss. Even more amazing is their opposite leaf arrangement. Leaves grow symmetrically in pairs, like installing 360 degrees light panels on plants. Each leaf can maximize sunlight reception. Even when blocked by other tall plants, can adjust leaf angles to catch light through gaps. Besides strong adaptability characteristics, Lamiaceae plants generally carry biochemical arsenals. Volatile aromatic oils in Lamiaceae stems and leaves, like menthan, carvacrol, not only repel pests like aphids and leaf beetles, but can also be released into soil through rain, leaching, or residue decomposition, producing allelopathic effects, thus achieving the goal of inhibiting other plant seed germination or seedling growth. Let me give you a real case. Wild mint in farmland releases terpene compounds. Nearby wheat and rapeseed seedlings show short root systems and slow growth. Under roadside basil clumps, few other weeds can grow to its height. This exclusivity gives them full advantage in competition. And Mosla's dense root system competes with crops for water and nutrients. Third, let's discuss identification features of 3 typical Lamiaceae weeds. 1. Mosla, the disguiser in farmland. Mosla is a biennial herb, stems erect, much branched, densely covered with backward pubescence. Its basal leaves are rosulate, leaf surface wrinkled like lychee skin. Mosla's verticillasters are pale purple corolla bilabiate, resembling miniature version of sage-2, ground ivy, the invader with stolons. Its stolons are up to 50 centimeters long, rooting at nodes. Ground ivy leaves are reniform margins with round teeth. Pale blue bilabiate flowers axillary in pairs, like mini wind chimes. 3. Hemp nettle, shadow killer of forest margins. Hemp nettle is a perennial herb, stem hollow, densely hispid. Leaves ovate cordate, margin serrations with hard tips. White bilabiate flowers clustered axillary, corolla tube, up to 3 centimeters long. Okay, let's summarize. Through today's lesson, we unveil 3 veils of Lamiaceae weeds. They are standard models in morphology's eyes, square stems, opposite leaves. Bilabiate flowers. They are survival masters in ecologists' writings. Flexible reproduction, wide adaptation, allelopathic competition. They are management targets in agronomists' minds, need scientific identification, comprehensive control, precise measures. Finally, let's end today's lesson with a verse from British poet Blake: to see a world in a grain of sand, and heaven in a wildflower. Lamiaceae weeds may be tiny, but their stories teach us only by understanding nature can we live in harmony with it. After class, please observe Lamiaceae plants around you. Try using today's learner methods to identify them. Perhaps you'll discover a hemp nettle disguised in a vegetable plot, or a cluster of quietly blooming ground ivy.